All right, looks like we've got a good quorum of folks now, so we can get started. And welcome to CDM October. And the first topic here is around telemetry and performance information in particular. Laura, do you want to take it away?
So oh, perfect. You already shared the Etherpad. And you can hear me okay? Perfect.
Yeah, sounds good.
I have a presentation to share. So, well, first off, I'll share this Etherpad that's also in that index. But if you prefer, the presentation I'm giving today is also in Etherpad form. So if you prefer to look at the Etherpad format of it, that's what this is. So I will just share my screen and get going here. Okay, so I'll just be giving some updates about the telemetry performance channel today. Some background, again, you may have heard this already, but I'll just go through it really quickly. What is telemetry? The telemetry module collects anonymous data about users' clusters, and this data, which is displayed on public dashboards, is used by Ceph developers to understand how people are using their clusters and to identify any problems that users are experiencing. The telemetry module is broken down into several channels, each of which collects a different set of information. So the basic channel provides some basic information about the cluster. The crash channel provides some information about daemon crashes. The device channel provides some information about device metrics. The ident channel, if users opt in, provides identifying information about the cluster. And the perf channel, which is what I'll be talking about today, provides performance metrics of a cluster. As developers, we might want to use the perf channel to understand how people are using their clusters overall, discover the distribution of different kinds of operations used throughout a cluster, identify any changes in a cluster usage over time, or determine if the system is performing as expected. And then on the customer side of things, since customers also have access to their own individual telemetry reports, they might use the perf channel to reveal detailed context about their cluster's overall health, identify patterns in their workload, troubleshoot issues with latency, throttling, or memory management, or monitor their cluster's performance by daemon types. What is the perf channel currently collecting? So the first set of metrics I'll talk about today that we are collecting are perf counters, where the perf counters, the way we're deriving that is through the manager module. There's a method called getAllPerfCounters where we can fetch those counters, and they're filtered where only counters that are considered useful or higher priority are being collected. We are collecting perf counters to get a better sense of how a workload is managed across daemons. And as you can see on the right side of the screen, I have sort of a JSON skeleton of what this might look like in the telemetry report. Each of the sets of perf counters are divided by metadata servers, monitors, OSDs, Rados gateway, and one example of what somebody might gather from these perf counters is if you're looking at the Blue Store priority cache counters, these counters are useful for diagnosing problems with memory consumption in OSDs. Another set of metrics we are collecting are OSD perf histograms, which is being derived from the output of Ceph OSD perf histogram. We are collecting OSD perf histograms to gather information about read and write operation latencies across OSDs. And again, I have a JSON skeleton of what this might look like in the perf report. There are 4 particular histograms that we are currently collecting. Each one offers a little bit of different information about read and write operation latencies. And a future use case of these histograms might be to represent, since they're 2D histograms, we might represent these as more user-friendly heat maps on the telemetry public dashboard, which is hosted by Grafana. Another set of information we're collecting is IO rate. IO rate is being derived by fetching it from the manager with the get method. And we are collecting IO rate to gain a better understanding of the changes in OSD IO activity between telemetry reports. In this JSON skeleton of what that might look like, I have on the side, we can get a pgstats delta, so a change in from when these stats were collected between the first time we collected telemetry report and then the next time, and so on. And then I'll go to the next one. The next piece of information we're collecting is StatSum Per Pool. This is data aggregated from fetching a PG dump from the manager module, and it's aggregated by pool. We are collecting StatSum Per Pool to learn how placement groups are managed in a cluster. However, we're currently aggregating these metrics by pool, but we decided through discussion that it would be better to collect this information at an individual PG level rather than at pool level. So that's a work in progress right now. So this might look a little different to you as we move forward with those changes. Another important thing I want to address about StatSum Per Pool is that we were originally including pool name in this report. However, we're removing pool name in a PR I have open right now because that could potentially contain sensitive information, which goes against the anonymous integrity of telemetry. The original intent was to provide some context about how the pool that we're collecting, in what way it's used. For instance, is it a manager pool? And there are certain default pools that we're interested in knowing that, but the way it was implemented, it could collect pool names that people create themselves, which is not what we want. So we decided it best to remove that field. Metrics still need to be added to the perf channel. One metric we're interested in collecting is Mempool. This can be derived from the output of Ceph OSD dump mempools. We want to collect mempool stats to see the number of bytes and items that each type contains, and from that derive which types are consuming pool resources. And the addition of this, the mempool stats, is addressed in a PR I have open right now, if you're interested in seeing the implementation. And I have a skeleton of what that might look like. It's really similar to the output of what you might see from running Ceph OSD dump mempools. Another metric we're interested in adding is compaction, RocksDB compaction. This data can be derived from the Ceph RocksDB parser that's currently out there. Mark is the author of that, Mark Nelson. We want to collect compaction stats to check whether the RocksDB compaction process is working as it should. And normally this process should take a second or two, but we might find by collecting these metrics that it's taking longer than expected. So that will help for troubleshooting or improving the compaction process. The skeleton I have, JSON skeleton I have to the side, is just about my interpretation of what that might look like. This doesn't exist yet, but once we are able to extract that data, which Adam is currently working to do, he did a lot of work to extract those counters. This is what it might look like. And that's our work in progress, extracting that data that we're going to discuss at the later telemetry huddle this week. Final slide, which metrics still need to be added. Customers have expressed interest in knowing how often and in what quantity data has been unavailable in their Ceph clusters. And Mark and Brett brought this up, that customers are curious. So questions that need to be answered about this idea to address unavailable data. Should we collect metrics per PG rather than per pool? The answer to that is probably yes. And if so, which metrics do we need to collect? And then to answer the how often of that question, does a measurement or counter exist that is being reset to help us distinguish between unavailable data occurrences? Can we miss the window when these occurrences happen? And then lastly, what are some possible reasons for data being unavailable that would be possible for telemetry to detect? And this idea is probably the least fleshed out idea we have, but it's still really interesting to talk about. So maybe you all will have some ideas about what kinds of metrics would be helpful in detecting occurrences of unavailable data. And that's all I have to share for this presentation. While I have the slides up, does anybody have any questions?
I have a quick question about number one. What's the motivation to collect the per PG stats instead of per pool? Do we expect that, like, a lot of variance between PGs, or?
Which slide was this?
It was your first question. I think it was one of the earlier slides where it's, yeah, per pool.
Or was it Mempools?
No, it was the PG, collecting stats on a per PG basis instead of per pool. So I think it's StatSum Per Pool was the.
Oh, yeah. This, yeah. So, yeah, right now we're collecting it by pool, but we decided that instead we would want to go on at a PG level to collect metrics like PG log length, because when they're aggregated by pool, it wouldn't be necessarily helpful to us. What was that?
You don't see outliers, yes.
I'm not getting what you're saying.
Yeah, that was the idea, Sage. So for like things like PG log length and like, recovery stats and scrub stats, etc., PG level things are more useful. But I think the general idea was there are some metrics that make sense on a pool basis, like, a number of bytes and number of writes, all that can still be useful on a pool basis. But there are certain metrics that if you aggregate on a pool, it doesn't make too much sense. So for those, we need the PG level stats.
Yeah, okay.
Yes, thank you, Neha. Yeah. So yeah, maybe we'll decide that we want to keep StatSum Per Pool in, but either way, we're missing that PG level, logs that we're not getting here. So that's it could be an addition, or we may not necessarily remove this altogether. But yeah, either way, we're not addressing things at a PG level when we should. So.
Did we talk about maybe summarizing the like the PG level stuff rather than collecting it all? Like if we had like a histogram or a distribution over the pool rather than collecting each individual PG.
Mm-hmm. Yeah.
But that gives enough information.
Yeah, we could do something like that. I know that we were interested in collecting PG log length, so I need to go through and see what we're able to extract from PG dump, because that's where we'll need to look most likely, and depending on what we can extract from that, we can include some more helpful data that could be processed later.
Sure.
One of the things too that might be important too is that we may not care about PG log length until we do, right? Like if it's crazy. Sure. So it might be something where we can, if we see something that's really outside the norm, we want to record it, but otherwise we don't care.
So yeah, like having a threshold, right? So that if it's above the threshold, that's when we start capturing those. But yeah, I think it'll be useful exercise to go over, what stats are there in the per pool that we are collecting and which of them actually don't make sense on a per pool basis and need to have a separate aggregation at a PG level.
Yes, yeah. And also, speaking of aggregation, a lot of the metrics we have right now, for instance, if we go back to Perf Counters, OSD is aggregated among all OSDs, so it's every single OSD combined because they all have the same schema. But for certain things, we were discussing in the telemetry huddle that it might be better to view these metrics with OSDs or by OSD separated, because looking at it averaged together isn't, or summed together isn't necessarily helpful. So there's some evaluation going on right now about that. I don't know if I forget if we discussed this piece specifically, but in other parts where OSD information is being collected, it would be better to separate them out.
I think it would be helpful to have a pilot on the LRC and see exactly the reports that we can have from this cluster and have it evaluated and see if it makes sense to aggregate some of them or have it separated per OSDs or per PGs. And if this data is actually useful, because if we have everything aggregated and we cannot derive real problems that we see in the cluster, then it might be useless.
Yes, exactly. And that's one of our next steps to put this on in a long running cluster and see what kind of metrics we're getting. And I feel like we're getting closer and closer to what we're looking for, especially since our last telemetry huddle discussion, where a lot of these, which metrics still need to be added, things were brought up. But I think we're getting to a really good place. And really what's happening right now is I'm working as quickly as possible to get these things added in so that we can get it on the long running cluster, because I think that'll be the most telling piece of information. Are there any more questions?
Yeah, maybe if there aren't any other questions, maybe we can go to the open questions slide that you have and just try to brainstorm. So yeah, I guess before we answer these specific questions, my general question is that, what do we want to infer? Like, data can be available for a minute and data can be available for hours. So I guess we only care for long-term data unavailability if there is, that's the pattern in my mind that I think will be more useful. But I'm curious to know what other ideas folks have around data unavailability and what that could tell us from capturing this kind of data.
That's a really good point, Nia.
Mark, was there any specifications in Brett's discussion that you had? So our customers specifically, do they want to know if data is unavailable for, just like Neha said, long term or, few hours or a few minutes? Was this discussed with Brett?
No, it was a very kind of high level statement. Basically just that customers, I think, wanted some kind of indication very generically of when data was unavailable and for how long. But I don't think that there were necessarily any specific requirements around that. Just I think the thought right now is more or less that something rather than is better than nothing. So I think that's up to us.
Yeah, you could think of it like looking at like a Ceph cluster SLA, like what is the availability that a cluster is providing over time? So what fraction of the time is it unavailable? Is it like 1 9, 2 9s, 3 9s, 10 9s? Probably not that many 9s, but it depends a lot on the hardware and the setup, right? So it would be interesting to see across clusters.
Yeah. So go ahead.
Like, what window are you looking at too, right, Josh? Like, you could go back for years on this, or you could go back like 3 months, and
right.
It's not. Yeah, it's up to us, I think, how we want to do that.
Yeah, the general measurement would be like the availability of PGs. So what states PGs are in. So we could certainly identify that. We already have PG states in Laura, Yarit, can you confirm?
We already have PG states.
Yeah, are we capturing PG states in our telemetry reports already?
I'm not sure. I don't think we are in the perf channel, but we might be elsewhere. Do you know, Yuri?
I don't think we capture the PG state.
Yeah, I'm looking right now. I think we don't.
Yeah.
Well, that's definitely what I mean by capturing things on a PG level. We're missing, so that's something that I'll add in.
Yeah, so I think that'll be a good start, I believe. So I think we have the total number of PGs, if I remember correctly, in the telemetry reports, but what states they are in is not there. So maybe just have that to start with. And then we, as Josh was talking about, like over time, we see how, what the distribution looks like, how long PGs are not all active clean or like in the desired state. That is something we can infer.
Yeah, in terms of availability, I think we mainly just care about active or not.
Yeah.
But other states could be interesting too, like how often are they inconsistent?
Yeah, inconsistent. And then we also have some hardware metrics, like we have some IO errors, etc., that we are capturing already. So is there a correlation somehow, or is it consistent because of a bug or something?
If we're capturing the states and like summarizing them similarly to like StatSum, where we say like this many PGs are
exactly
active clean, this many are in recovery.
Yep.
That would be really interesting for people to see, like what the recovery time for the cluster looks like too. Like how many PGs are recovering over time after some event happens, and
yeah, this is sort of independent.
What we need to do is just report the states of the PGs, and then from the server side, maybe you're saying we could take that and then sort of derive what we need from that.
I was just thinking that even independent of telemetry, one thing that the Ceph cluster, it always shows you a snapshot of what the availability is at a particular moment, but there's no like summarizing over time. It would be interesting if the cluster could track its own like availability over the last month or year or whatever it is. So you can actually see how many nines for each pool you're getting.
Yeah, it'd be a really interesting thing to visualize in the dashboard too, I think. Like the history of the cluster availability or other aspects there.
Yeah, and then we can have this information sent in the report. So that's what I was curious about, whether if we just have a snapshot, does it tell us enough about what happened in the meanwhile in the cluster? So it'd be good to have this tool on the cluster, and then just to have this output sent through telemetry.
You can imagine that long-term users being able to look at their own availability compared to other clusters' availability, and then some kind of deeper dive into why is theirs better or worse. Like a really useful thing, I would think. That's much later, but that might be eventually an end killer feature here.
And I'm liking that this is a concrete thing that we can metric that we can take, because I wasn't sure up until this point really what metric we would need to grab, or even if we would need to add a new counter or anything. So it seems like we're already we've already got this metric and we can extract it and report it. So that's really great, and that'll work us more toward the goal of grabbing data on a PG level as well, just in general.
In terms of the time aspects, like the windowing, sampling is certainly much better than nothing. Like we could also add something like a histogram over time for like which days PGs were in for the course of a day, for example. Like this many PGs were in this state, active and clean for this much time.
This seems like another area where triggers are really useful, right? Where you maybe want to be able to say, trigger recording an event when this went down, when it came back up, right?
Yeah,
Possibly.
for those who don't know, Mark has been bringing up this idea of using a telemetry in a triggered way. Right now, it just reports everything between intervals. It reports all the metrics every time, but Mark has brought up a few times using it more in a triggered context, like if this event happens, then we report this data. So yeah, something to think about for sure. This is really good. Thanks so much for the feedback in this context. Does anybody else have any other ideas about unavailable data in a Ceph cluster?
Yeah. Well, yeah, but please go ahead.
Sorry, go ahead, Ernesto.
No, it was just a China thing. Paul Kirchner is now working on exposing the tech health checks via Prometheus, so they will be now available. Not sure if that might be also interesting to have those events, and I don't even know how to do that in the telemetry if that ever happens. The PR is this one. So maybe it's worth it just to see. We are also triggering alerts from that. So yeah, if we can somehow connect that, if we can get any interesting information from that, well, just for you to know that that's going to be also available soon.
No. So this is happening in a PR that hasn't been merged yet for Prometheus.
Yeah, that's the Prometheus module, but I think Paul planned to persist that on the Mon key-value store, so that might be available for other modules as well. In fact, there is a CLI command for that, so if you want, I think you can consume that from the CLI.
Oh, perfect.
We might want to discuss more about that persistence. I think we just got rid of that persistence for exactly the same data from Insights because it was too overwhelming to store that for the month, so we want to be really careful about that. But we can follow up on the PR.
Sure.
Thanks for bringing it up, Ernesto.
I'll let a comment to Paul on that regard, on the potential risks of storing data in monitor KV for this.
Okay, cool.
Yeah, I guess we've figured out which metrics we can collect for this problem, and the last thing that I can see still needing some answers is the third point on there. What are some possible reasons for data being unavailable? It seems that PG state mainly answers that, but who knows? Or I don't know. There could be another reason for unavailable data that we're missing. So that would be another thing to consider. Maybe it can be collected by a different metric as well.
Yeah, I was about to ask Neha. Brett mentioned the Slowups that we might want to consider, but he said that you probably know best.
Yeah. So I guess I'm a little skeptical about Slowups. Slowups can be for a lot of reasons, and I think a lot of the information that we are collecting will probably not be enough to even infer the reason for Slowups. For certain things, it can be like let's say there's Slowups because of a network issue. We have indicators of slow ping times between OSDs, etc., that we capture. It is part of a separate command, and it is also part of Ceph status. So there we can infer things, but in certain cases, if just things are slow momentarily for just backlog or just the system being slow, those kind of things, I'm not very sure Slowups are going to be really useful to capture there.
Okay.
That's good. So yeah, we can rule that out because that was brought up as a possible metric. But yeah, maybe it's just better to rule that out.
I think, yeah, that let's consider that as phase 2 or something, because that would need us to at least have these bare bones first, right? If PGs are not available, and we know that from the PG states, it is expected to have Slowups, right? So that time Slowups is not going to be very useful. But if the PGs are active clean and still there are Slowups, those are the cases where there could be a network thing going on, or just like a backlog. Somebody wanted to say something. Sorry.
Yeah. I just wanted to say that when someone complains about like their cluster being slow with no further specifics, which we often see on Ceph users' mailing list, the Slowups warnings is something that is like the first thing that we look at. And it is often the case that the PGs are fine, or maybe a couple of them are degraded, which doesn't mean that which isn't supposed to bring any slowness to the system, but the warnings are still there. So I think this is a very useful metric, or just recording that the Slowups warnings have been there for this much time is, I think, very important, because when someone complains about, again, my workload just was stuck for a while, and now it kind of resolved itself. We want to know, and we want to see that the time and maybe the number, and see which pools were affected and things like that. Just a general observation that the Slowups warnings are really one of the first things that anyone looks at when starting with an unknown cluster.
Yeah, I think we had some thoughts about, I think Vicky was talking about some different ways we could try to build in more analysis capabilities to try to figure out where those are coming from. I think that's maybe a larger project. We do have some data, though, even with the perf channel coming in about latencies and histograms of latencies over time. So that'll also give us a view of, like, if there's tons of slowness, we'll see that just from the perf channel, regardless of the Slowup warnings or not.
Yeah, I guess what I was trying to say is that what we discussed earlier, and in terms of the perf channel, kind of gives us the root cause of a Slowup, right? If there is one that can be identifiable. But in general, if we capture that, we should be able to say if the system is functioning fine or not. Just capturing Slowups sometimes may not be enough, because you need a lot of historic data about, like, the logs, let us say the cluster logs and OSD logs, etc., etc. That may not be possible to collect just by means of telemetry.
Yeah, I think that's a good point, that we can use the data the other kinds of data that we're getting to diagnose the Slowup, because the sense I get is that it could be caused by the Slowup itself just implies slowness, but that slowness could be caused by any number of things. So it might be better to know any number of things rather than just the Slowup. But
yeah, I'm not opposed to capturing both. We can capture both, and then again, as we said, that capture some of that data in an LRC cluster, and see how useful that is, and what we can infer and what we cannot, kind of stuff.
Right. Yeah, that's a good point about collecting both too. I mean, if Slowups are indeed accessible or available to collect by telemetry, I would have to look into how we could collect that, but I wouldn't be opposed to collecting both. And then, we've discussed it's always better to have a little bit, not too much information, but a little bit more information than too little information. So, it could still be helpful.
Yeah, it seems like the Slowup piece gives me something that we could follow up on later. It doesn't have to be part of the initial availability piece.
Yeah, I think the first step should be to collect PG states, and then since we don't even have that yet, collect PG states, and then see where we are with that, and then have Slowups sort of in there as like a possible next step that we could do after we get this first step done.
Yeah, it's really more of like a performance diagnosis sort of thing.
Right. This is really great. I'm really glad for this discussion. We've hit on a lot of points. Is there anything else that anybody wanted to bring up?
I wonder if the collection of the data should be added. So if we just add things to the perf channel, we might, there might be data from the cluster that we would really like to have in case the user is not opted in to the perf channel. So I'm considering whether redundancy is a good idea in general. But so, for example, if we would like to know the states of the PGs and the user is not opted in to the perf channel, maybe it can help us in general to have it in the basic channel. But again, that means redundancy. So,
well, I was going to suggest that we should just, for any given piece of information, we just decide which channel it fits most naturally in. And for PG states, that seems like less of a perf thing, and it should just go in basic. No reason to necessarily duplicate it. But I mean, that brings up the other point, though. I wonder if it would make sense to just briefly summarize what we came up with, I guess, a couple of weeks ago now in the telemetry call about how to version the channels to deal with that, so that people don't have new things start getting sent that they haven't opted into, but also they aren't sort of forced to turn things off if something new comes along that they don't like.
Yep, exactly.
Yeah. Do you want to summarize what we? I think I remember what it was, but
yeah, I've forgotten exactly what we said.
Well, I think you remember probably better than I do, so maybe you can summarize quickly and we can.
So I think we said that we can opt into a version because we said that the changes will be in like in a major version. So if we were opted into Octopus, so we have everything which is Octopus related. But then we, if I remember correctly, we could not decide on backported data to Octopus, for example. I think there was an open piece that we did not solve.
I think what we decided is, we went around in circles on that a bit. I think, and basically, instead of having a channel be on or off, it's on at a particular version. And initially we said releases because normally it'd roll this out, but if we just make it a version string, then that would also let us backport things if we wanted to, and then you could opt in. But basically, when you enable telemetry on a channel or enable a channel, you can either just turn it on, in which case it'll by default opt into whatever the current version is, or you can opt into a particular version of whatever that channel is. So you could opt into what was being reported in Octopus instead of in Pacific, for example. And then there might also be an option where you can opt into like any future version too, although I'm not sure that it would be wise to suggest that people do that. And then I guess the missing piece is that we would need a programmatic way to, like a CLI command or whatever it is, that would dump like a nice summary of exactly what is added in any particular channel and version. So you would see that in the basic channel in 16.2.5, we added this field. And so it'd be like a JSON thing that would dump a bunch of strings that would like just describe what it is that is added, so that when you're presenting a dialogue or when you're asking people that there's new telemetry that would like to report, do you want to accept or reject it, then it'll actually show you what it is that we're asking to collect. I think that was the plan. I think that gives
that's
us, I think that gives us the flexibility to like put whatever new information that we want to start collecting in whatever channel we want, wherever it like fits most logically. Seems like a good thing.
Sounds pretty much like git diff to me. Like, you have different versions and you're doing a diff of what, and that actually makes sense. You know, that's very intuitive.
Mm-hmm. Yep. Well, to a developer at least, may not be most obvious thing to all users.
Yeah. Yeah, and we could expand the telemetry show command so you could show a particular version, what it would report, and then you could diff between two versions, or I don't know, whatever. Yeah, you could do all that stuff offline, but yeah. Yep. So there'd be a bunch of enhancements to those commands to make the whole thing complete.
Meeting is recorded, right? Because we're saying a lot of really good things.
Yeah.
Okay.
You try to write them down and then etherpads too. We don't forget this time.
Yeah. This might be a good one to write up separately as just to describe this whole scheme. And I don't know, because this is something that we have to complete before Pacific.
Yes.
Not Pacific. Quincy, before Quincy. Yep.
We've got our work cut out for us, but always good to have it written concretely down. So I think that after this meeting, maybe I can start an Etherpad and people can add, just for versions, and we can add a little bit to that. I can add it to the telemetry index Etherpad.
Sounds great.
Sounds good.
Nice to have a Trello card for it as well.
Yeah.
Yeah.
Sounds good. At the risk of introducing 100 more problems, is there anything else that people would like to bring up about telemetry? I know there are other topics too for CDM, so I don't want to take too long, but else before we wrap up. All right. Sounds good.
I think the next topic then is the Boostor SMR.
Or SMR support. Okay, so here's the pad here. So basically I just wanted to give a sort of a status update on where things stand. All the notes from our previous discussion that we had a call with Talib maybe like a month ago where we talked about, it was in the performance call, I think, where we talked about the current code that's in the tree and what should we change. So I've been working on a pull request that makes most of these changes, and that's basically ready to go. It has a bunch of patches on top that address the most recent review from Igor. So those aren't squashed yet, but as soon as he takes another look, then I'll squash this down and I think it'll be ready to merge. So basically the current status as of all of that is that all of the internal metadata tracking is implemented so that we can, and a simple cleaner is implemented. And so we can actually, Boostor will successfully run on an SMR hard drive, or at least on one of the simulated ones. I don't think we have actually tried plugging in an actual one. Currently, it takes, these SMR drives have a small space at the beginning that has conventional zones that work like a regular hard drive. That space is reserved for BlueFS, and so all the metadata goes there, and then all the sequential zones that have the SMR semantic behavior are used for actual Boostor data. So right now, Boostor just does that, unless you give it a DB device, in which case it will put all the metadata on the DB device, and all the data on the sequential zones, and the conventional part will be ignored entirely. So wouldn't really recommend that necessarily. That's fine, I think, for now, for like all the use cases that people will probably use these drives for. There's going to be enough space in that conventional zone for it. But there's lots of things you could do in the future to make it like spill over better, so that if you had a lot of metadata, it would spill into the conventional zones. It is possible to put RocksDB on top of that part of the drive without any real trouble. But yeah, so it's basically, it works. You can run the Ceph test object store tool, and it'll drive to completion. Some of the tests get skipped because the tests are checking like statistics and other specific bugs and so on that like don't really make sense with the SMR drives. So there's some tests that are skipped, but otherwise it looks like it's in pretty decent shape. But it's totally none of the like policy stuff or tuning is particularly smart. So as far as what the next steps would look like, I think the first one is figuring out how we want to build. Right now, you have to link against this libzbd library in order to use the SMR drives. There's a copper repo that Kifu created that I was using for my testing. There are currently no Debian packages. I think probably what we want to do is just either build some of these ourselves or go poke somebody and get those into whatever distro so that we can just build. Have the standard builds that we do link against this package. We could actually even just not link against it in the Debians. That might even be okay because the container image is based on CentOS, and so as long as the support's there and most people are using that, then we capture most users, at least for the short term. But once we do that, then we can have pathology tests that exercise this code by like running the Ceph test object store tests against a simulated device, for example, and so on. And people can actually test deploying it on real hardware. And I think actually we have all the pieces we need. I think the copper repo that Kifu has is sufficient for that. We just need to change the container image build for master frequency. So I think that's probably my suggestion, but I wanted to get feedback on whether that makes sense to add that dependency. That's probably also a conversation that we should have with the whatever the rel people or whatever in the version 9, so that this is make sure that that library is going to be supported in the future. Anybody have any thoughts on that? Should we go ahead with adding that linking, or?
Well, if you're talking about the existing libraries and distros, that might be tough to get anything new in at this point. I think it's fairly late for like next versions, but if it's something that we could like ship with Ceph itself, I think that would be fine.
Yeah. Actually, I guess it's tricky because so it's easy to get the libzbd installed in our container image because we have the package and we can just add it in. But it's a compile time option that compiles all the stuff in. So if the library is present, then it enables all this extra code, which means that it also needs to be part of the like standard RPM build process, which means that it has to be installable for everybody who downloads like the CentOS RPMs. So this would be like, and I'm not sure I don't think we require people to enable any extra repos. It has to be, we'd have to make sure that libzbd basically is in EPEL, I think. That's what we ask users to enable. So maybe that's like the to-do.
Or we could even distribute it ourselves through the Ceph repo if we wanted to, right?
Yeah, but we don't make people enable special Ceph. Oh, I guess we could. Yeah, that's true. Yeah, that probably has its own set of weird issues. I don't know exactly how that works, but yeah.
It might be simpler even just to statically link instead of trying to get into all this everywhere.
Yeah. Okay, so probably need to have a conversation with Ken or Keith or somebody to see what makes most sense there.
Yeah.
But I'm inclined to do this sooner rather than later because then we can start doing the testing. And we can do it just on master. We don't have to worry about all the old distros because this is all new code.
Is the libzbd, I mean, it seems like it's a pretty new thing, so is the version we want in any distro at this point?
Yes, that is my understanding is that is the way forward. There is a kernel driver that allows you to interact with SMR drives like via some weird like fabricated file system where each zone becomes a file that you can append only to, and then you delete whatever. There's like this like quasi file interface, but that's only in really new kernels. Whereas libzbd is just interacting with like whatever, sending like SATA commands or something, talking to the block device. It's a little bit less annoying. So I think it's the way to do it. And that choice came from Talib, so I sort of trust it.
Yeah. I wasn't questioning the choice of the library, but more whether is it available anywhere yet in a real distro, like, or is it sort of another thing that it's not really good yet?
Question.
I don't think. I don't think so. It's available in any of the the standards one we are using currently seems it's targeting for Ubuntu 21 and Debian.
Yeah.
So I think going with adding it to Ceph itself would be the best option. I can help with that. I have for Jaeger similar case.
Yeah. Okay. Yeah, it is in Debian SID. I think it's going to be. It's in the pipeline, I guess, but it's not in the current table that we target. Okay, so that's the first thing. The second thing is the cleaner. So the cleaner that's currently implemented is like the simplest cleaner basically that you could implement. So it just sort of right now in the tree it wakes up like very aggressively just so we exercise the code, but that's not actually what you want it to do. So there's a lot of policy around deciding when to clean that needs to be tuned. And it doesn't, it's not super efficient. Like it'll take one object, it'll read the whole object, the parts of it that are in the zone you're trying to clean, and it'll rewrite them somewhere else. But it doesn't deal with clones very well. So if you have a cloned object, it'll basically rewrite that data twice for both objects. It'll read it and rewrite it separately. So it's not suitable for like any Rados pools that have snapshots, for example. It doesn't like think about compression or trying to preserve any of those things. It just sort of blindly rereads and writes. So there's lots of work to be done there to like make it better. But I think it would be sufficient for like the use cases where we would actually recommend SMR, which is probably like RGW workloads. I think it's sufficient. The rewrite behavior is sufficient if you add all the tuning and when to wake up and throttling and stuff like that. But yeah, I think this is the primary thing. This is the primary area where I think Talib and his students want to focus is like all the policy and testing and performance discussion or whatever around when and how it should behave, and less about like the Blue Store implementation details of how metadata is modified and so on. Yeah, there's like one other thing here. There's like one lookup method that's needed in Blue Store so that we can go from an object to a handle to the collection, which is something that you normally never have to do in Blue Store because in the OSD you're going the other way around. But current implementation just like enumerates, tries every collection to see which one matches the object. So I need to fix that still, but that's a relatively small piece. Then there's the conventional zones. How do we want to use them? Right now, they're just given over to BlueFS entirely. And then Blue Store data uses the sequential zones. It is possible for BlueFS to use the sequential zones. Like the SST files are always written sequentially and read once, and like actually they're very SMR friendly. So that would be a pretty easy thing to do. And it would even be possible for BlueFS's like internal logs or the RocksDB log file to be written on sequential zones if you really wanted to, but that would be more work because we'd have to deal with non-block aligned appends and rewrites and whatever. There'd be some annoying implementation there if we really wanted to. But I think that work is entirely
Actually, BlueFS log is easy because it's already aligned. The only problem is write-ahead log of RocksDB. That will be tricky.
Yeah, you're totally right. Yeah. And it is doable, but it is sort of tedious weirdness. I think for these SMR drives, it doesn't matter because there's always going to be that conventional zone, and there's always going to be plenty of room there for those RocksDB log files, even if that were the only thing that were going there. But if we want to run these against, for example, a ZNS SSD, which has almost the same interface, except that there's no conventional region, then we would have to deal with that RocksDB piece. But I see that as being like something we can kick that can way down the road because there's no like time pressing reason why we have to deal with it anytime soon. And the long-term plan for ZNS SSDs is Crimson and not this Blue Store modification. Igor pointed out that in FSCheck, when it's scrubbing all the zone references, it's building a big in-memory map that might use too much memory. So probably some cleverness needs to be done there to make fscheck less memory hungry. I think that's a lowish priority in the short term when we just want to like make sure everything behaves and is correct. And then the last thing I wanted to flag was that I think it probably makes sense to make a different, from a user perspective, to make a different OSD class so that, different OSD class for SMR drives because they behave, their performance characteristics are so different than hard drives. So right now we have SSD and HDD are the two automatic classes basically, but we could, my suggestion would be to have an SSD and HDD and an SMR HDD or just SMR or something like that for these SMR hard drives, so that you could have, crush rules that take that in, that are using just the SMR drives for the bulk storage pool, or even just so there's some visibility when you're like dumping OSDs or whatever, you can see that these OSDs on SMR drives are going to perform very differently than conventional hard drives. And that's it. That's all I had.
Do we have any workaround for that annoyance that SMR write pointers can only be read in privileged mode? I had to run all the tests as super user, and I prefer to do that as normal user, and that wasn't possible for the SMR.
Yeah, I just was also just sudoing before I ran the test. Yeah, it is annoying. That's a good question. We also, that might affect also the OSD, whether it can, like when you're resetting the zone pointers, I'm not sure if you have to be super user or not. So the OSD might not be able to drop privileges as well. Yeah, I'm not sure about that. That would be nice. That's probably a question for Talib to see, Let me make a note of that. Any other questions, comments? Nope. All right.
Cool. The last topic at the moment is RPD mirror Prometheus integration. Who would like to speak about this one? Sunny?
Yep.
Go for it.
Okay, so basically I am just going around and doing some experimentation around the idea I shared. So what is the motivation behind this experiment? So basically to enable users to monitor the health of asynchronous replication and detect anomalies. And another high-level goal is to provide a consistent way to deliver matrices and alert for cross-cluster replication. So as I told before, the more detail, high-level detail can be found here. And it contains all the idea gathered at single place. So as you can see in main idea, there are a lot of target things like we can use it as a CLI or can be used in dashboard to publish metrics. So here in this experiment, I am using Prometheus as a consumer to this exposed matrix. So basically, this is just a definition of Prometheus. Who are I think everybody is aware of what Prometheus is, but just iterating. It's just a simple service monitoring system which collects metrics at a target at given interval, which can be configured, and it has its own rule expression and query language which we can trigger and get the exact result based on matrices which are exposed at a certain points, like exposed point, you can say. Yeah. So another thing is important about Prometheus is it basically collect metrics via a pull model where you expose your metrics at HTTP web server. So next one, what we need to do to be consumed by whatever metrics we expose to be consumed by Prometheus. So what we need to do first, we need to add instrumentation to our code. Whatever code, like whatever metrics we want to expose, we need to instrument them, and these we can do via Prometheus client libraries. So it's completely related to RBD, and our code base is in C++. So we need to look at Prometheus client library, which matches C++ language. But unfortunately, there is no C++ client library official. But basically, how this client library will help us in exposing internal matrices. So this client library actually helps you to first define and expose internal matrices and expose at particular HTTP endpoints where Prometheus can come and gather all the metrics. So what are the options we have? As I said earlier, that there is no official C++ module client library is available. So we can implement a new one, which guideline is pretty much available, and it's well documented at the Prometheus official documentation link. And we can use any unofficial one to which is already available and written in C++. So such library is this one, Prometheus C++. So what this C++ Prometheus CPP library does, it is actually very simple and a small library which is completely written in C++, and internally it uses Civet wave to as a HTTP web server, and it has three main components. One is core, another one is pull and push. So it is complete module is divided into three parts. So basically core is more responsible and where all the instrumentation and how to expose metrics and each and everything is code is there, and pull model where we can use this library wherever you want to pull matrices from a particular endpoint, such as is our case Prometheus. So that's why we will be only interested in these two components. So how actually it works? So as I said before, it is divided into three main components: core, pull, and push. So core component has two main components. One is registry manager, which actually has tools and instrumentation to implement a global registry where we can capture and put all the matrices. And another one is matrix endpoint, where it provides an interface to basically implement and expose those matrices to a particular defined target, where by default target for Prometheus to pull it is slash matrices. So it does the same. It actually by default exposes all the matrices and bind these to a particular endpoint that is slash matrices. So in this experiment, actually, as we can see, this complete data pipeline is divided into two parts. One is producer and another one is consumer side. So consumer side basically starts with controller, and controller actually calls the export, and it sends the matrix data to exporter. And a consumer side begins with a Prometheus pull request, and whenever Prometheus server sends a pull request to exposed HTTP point, it actually defines and gets a collectible interface, and it has a registry inside where we register for a particular endpoint, and it fetches data from there. So overall, this is a rough sketch how it actually looks like. So it starts from left, you can say producer side, where collector is collecting all the data, and exporter will and collector will export this data to exporter, and exporter has a job to basically expose HTTP endpoint and give the data to collector, where collector will have only one duty to gather all this data and wait for Prometheus pull request to fetch data. So this is how final, based on all this concept, I have created one simple app which basically just fetches the number of replicating image count from already defined cluster. So yeah, so next step we are looking at, I'm trying to implement a demand health matrix and finalizing more matrices. So there is a lot of scope to gather what kind of matrices should be included in this. So this is what I'm doing right now. So feedback and questions.
Hey, Sunny. Yeah. Well, looks really nice. I would like to ask a question about what's the plan for high availability here, because, for example, right now with the Prometheus exporter stats attached to the manager, we currently have three. Or in some scenarios we can deploy, for example, 3 managers. So we have kind of a replica 3 or 3 possible instances. So what's the model or high availability model for this?
So right now we are targeting it to tie up with to be tied with RBD mirror daemon. So it will scale with that. So
okay, so then we have time on stats rather than service, right? That's more or less the okay. Okay, and I have also questions about security. I mean, in the dashboard, we are also dealing with HTTP, and well, probably as RGW folks know too, that's quite an issue, right? So, are you planning to support TLS just for the encryption of the endpoint, and also is there any, security measures to control, because this basically might turn the daemon or its daemon, if this is the plan to extend for other daemons, right, as a potential DOS vector, right? So I'm thinking on throttling or some kind of content and attack if this becomes a public HTTP endpoint, so we can control that.
Yeah, sure. This is a really good suggestion. And I haven't looked at the security part, but it's in very initial phase. So we are gathering all the feedback, and we will just go through this. So really, thank you for this one. I haven't considered it, but yeah, definitely we have to do it.
Thanks.
So just to clarify, we're talking about embedding an HTTP endpoint in daemons and having Prometheus pull them for metrics.
Yeah.
What's the reason that we want Prometheus pulling us instead of our daemons just feeding metrics to an endpoint that they know about?
That I think Ilya would be the right person to answer this.
I'm not sure I understand the question. The daemon would expose a Prometheus endpoint because I mean that's how Prometheus ecosystem works. The data is pulled by Prometheus, not pushed by the endpoints. If that's what you're asking.
Yeah, I mean it's a topology problem. It's their strategy for scaling and avoiding a single sink. That's there'd be ways to do that, but it avoids a single endpoint bottleneck.
Yeah, so the goal with essentially embedding the HTTP server in these daemons is precisely avoiding to having to pump all of our metrics through the single through a single endpoint, which is what we currently do with the manager's Prometheus module. So what it does today is it grabs the performance counters that are sent to the manager by the various daemons, including RBD mirror, but there are only a couple, and makes those endpoints available as text using Python's CherryPy web server. This is perceived to be a bottleneck, especially as we plan to expand and grow the number of metrics that we're exposing and sending, and coupled with the overall manager scalability issues that we've been hitting in recent releases, we made the decision to get away from a single endpoint for the entire cluster and distribute them among the daemons. The RBD mirror and Ceph mirror daemons are the initial targets, but I think RGWs could follow suit. I think the Crimson OSD is also kind of up there because if I remember correctly, C-Star has an embedded Prometheus endpoint as well, and that's how it exposes the metrics, its own metrics, and I think Crimson OSD is taking advantage of that. So what we're doing here is just getting in, distributing the metrics and in making them highly available, because if one RBD mirror daemon goes down, you can it wouldn't be precisely the same metrics, but the Prometheus would be responsible for just fetching everything we make available and collating that. This is how Kubernetes works, and by removing the load from the existing module, Prometheus module in the manager, I think that's really, the only possible course of action at this point, because adding more is just not feasible.
Okay, so I was aware of the need to get the Prometheus or decouple it from the manager. So this new model would have multiple Prometheus endpoints, and they would all be polling from the daemons. Is that the way that this scales?
Now, each daemon would present an endpoint, and then what is pulling that endpoint is outside of Ceph. We don't care. We just make the data available, and I mean, we could still package some write up some documentation as far as what is exposed. Perhaps something that would closely resemble a schema, but in general, the pooling side of it is going to be outside of Ceph. I think that the existing Prometheus module in the manager would probably stay for a while, because not everything can be demonized this way. There are some metrics that are generated by like RBD top is one example. This is essentially this is a CLI command that, as long as it's running, it is sending stuff to the manager, and the Prometheus module makes it available. So for these one-off cases that we aren't sure how to address yet, the Prometheus manager module would still do would still serve and continue doing what it's doing today. But for stuff that is generated by the daemons, the goal is to offload as much as we can from the manager.
Well, it's just to answer Casey's question directly. I've heard this described a couple of times by Prometheus, most of the people working on the storage management team, and my understanding from that is that the strategy of Prometheus is that it can scale up into multiple daemons that can do this collecting work in parallel.
Yes.
Okay, and there's no push mode, so if we wanted to push, we would need something like the manager in between to hold on to things and get pulled by Prometheus. Is that right?
Yeah, there is no push mode, and just to be clear, what we're doing today is also not push. Well, to some extent it's push, because the perf counter data is pushed to the manager, but that's where the push ends.
Well, it's pushed from the point of view of the daemon, right?
Yeah, it's pushed from the point of view of the daemon.
About it.
But yeah, so if RGW is structured around pushing this sort of data, then yes, it would probably need to be restructured. but I think for like in general, even for like even if you're pushing today, turning that into a pool doesn't seem like it's going to be hard, because you could just like if you, for example, push every 5 seconds, you could just serve the same data and update that data every 5 seconds instead of actually generating a message. So have a little cache there.
Ilya, one question on behalf of the Ceph team, because I think Sebastian is on PTO this week. I will ask about how is there any plans to, because now we have to kind of orchestrate or discover different demos, right? And currently all the Prometheus configuration is managed by Ceph ADM. So there are just a few script endpoints, and that's quite simple configuration. But if this extends with this new architecture, with every daemon potentially having an endpoint, that will mean that we will need a way to either discover at service discovery, right? To find this or register every daemon in some registry or something, because otherwise, I mean, if Ceph ADM is launching the service, it can simply record that and, well, update the Prometheus thing, right? But for example, with Kubernetes, with Rook, or with but someone doesn't want to go with the Ceph ADM thing, how can we do this? Are you thinking about that? Are you planning something for orchestrating all the different Prometheus endpoints?
Yes, Sebastian was actually involved in these discussions. I don't have the specifics, except that what I seem to remember is that it is actually much easier to do this in a Kubernetes environment than it is outside of Kubernetes. And so the problem is actually raw Ceph ADM installs. The Kubernetes piece is taken care of almost automatically. Because again, this is how the rest of Kubernetes works. So it's not an issue there. It is an issue for non-Kubernetes installs because you're right. We need to, suddenly you need to get that, have a way to get the list of endpoints and somehow get that to Prometheus, or Prometheus needs to have a way to discover that. We discussed this a couple of times, and Sebastian is is definitely aware of this. I just don't have the specifics as to what the current plan to do it is.
Okay.
It does seem like Ceph Manager could still be involved here, since it.
Yeah, Ceph Manager could still make. Yeah, exactly. So I think that's that's more or less.
From a sequencing point of view, certainly, I tend to think that it really is a bottleneck, most likely.
Right, but it has the map of all the endpoints that Prometheus needs.
Well, yeah,
feed those.
Yes, right. Sorry, yeah, I agree with that. That sounds like a very sensible thing. I mean, one of the things I don't know if this isn't being addressed, but one of the things we've been hoping to see from this is additional types of counters, and it's not really the same thing, but it seems like it relates in terms of the work that gets done. I don't think it makes sense to try to change how manager understands counters if we're going to have another system at any rate. There are a lot of users of RHW who have asked for things like sparse counters, essentially. The number of most active buckets, or as well as our most active users are in quota-related stuff and things like that are things that people have asked for.
Those such counters things that Prometheus already supports, Matt?
Jason Tilleman believed that they were. counter with a tag equals value, or I don't know if tag was the right word or keyword. I'm not sure what the naming, what the terminology in Prometheus had them to be, but did seem to be such a thing.
Yeah, I think they're called labels, and yeah, I mean, it's fairly expressive. So it doesn't map one-to-one to Ceph's performance counters, and that is actually one of the things that by eliminating this performance counters bridge that we currently have, where the manager module takes Ceph perf counters as input and then outputs, Prometheus, HTTP, basically just text, structured text. The limitation there, which could be addressed, but just no one has done it, is that only a couple of Prometheus, I'm not sure what's the right word, but Prometheus has counters, has gauges, has histograms, maybe a couple of other entities that it supports. And we basically, the existing manager module only supports counters and to some extent gauges, and I think histograms get squashed, and you could basically say that they're not supported. If the daemon has is in charge of the daemon has the data that it wants to expose, and the Prometheus library that we are going to use would hopefully support all of these entities. It would actually be more expressive because instead of going via the intermediary, you could directly encode exactly what you want with the labels that you want. These are like key value pairs, and so I think as far as expressiveness, we would not lose anything, but rather gain quite a lot, because you could expose histograms and other fairly advanced things there. Prometheus has built-in support for them.
Basically, 4 things: matrices type like counter, gauge, histogram, and summary. And it's a job of actually this one, a client library to implement all these kind of matrices that you can put into your instrumentation and map these. So I think we need not to worry about too much about actually what kind of type of matrices. Just we need to worry about actually how we are going to map the required matrix that we want to expose with these types.
I see a mention of OpenTelemetry's minimal HTTP server in the comment. Is it used? Does OpenTelemetry also have some Prometheus integration, or is it just for its own?
Yeah, it does. It has several exporters that we put there. There's Prometheus, there's Ceph, and there's a few others. I'm not sure how complete they are. They look fairly minimal with my eyes, but I'm not sure how extensive they need to be for our purposes.
Yeah, I'm just like as mentioned in the comments. Maybe we should capture this discussion in the chat. But both myself and Matt and I think others feel that bringing in bringing back, I should say, the CivicWeb submodule as part of the Prometheus CPP library, which Sunny has been experimenting with, is not desirable. And even though it is not going to be used to an extent that it was once used by RGW, which is, by serving or handling actual data, this is just some text that we don't expect any performance issues with. It is still something that, if possible, we would like to avoid. And so one thing that was one idea that was floated around in the past was using Boost's Beast web server for this. But there's nothing out there that combines the Prometheus endpoint library with Beast. So perhaps we could bother from OpenTelemetry here and have a look at what it does, and maybe that's enough for our purposes, because we do need, this work needs to land sooner rather than later. So one of the reasons that we've decided to, or I guess that we went with exploring this existing library instead of just writing something from scratch based on Beast, is time constraints. We really need this to land in Quincy because of our downstream requirements. But if OpenTelemetry already has something that can be fairly easily incorporated, then maybe that's another approach to explore.
Yeah, certainly it seems worth investigating. I'm not sure what makes sense in the short term, but it might make more sense in the long term, at least.
Well, long term, I would really like to settle on Beast, not just because this is something that RGW already uses, but also just from the point of view of a web server, even if it's used just for serving up this Prometheus data, it's still a web server. It's still an attack vector, and having that and maintaining that, especially if we end up just cut and pasting from Open Tracing or some other project, is going to be a problem because no one is going to update that. So converging on Boost's Beast long term is definitely the goal. How to get there remains to be a question.
Mm-hmm. Yeah, it certainly makes sense in terms of maintainability and security aspects. Using a a web server with a good community around it.
So this client library, I mentioned Prometheus CPP, has, if we explore, I have explored this, and it's not that hard to move from Cvet to Beast. So I explored that part as well. So we can do that, it's doable.
Okay.
Oh, I hadn't realized that. If you actually look at that, and it's feasible to do. Let's say so it's not too much work, and it's would not delay us significantly. Then we should probably do that because shipping CivicFab. It's not just upstream, it's also downstream. A new submodule and would need to be incorporated into the build. Doing that only to rip it out in the next release would not be something that I would do, even given the time constraints that we have.
Yeah, sure. I can explore that part more and get back to you.
Yeah, and it looks like Casey's volunteering to get us some help. So, yep, let's focus on that and see how far we can get in the coming weeks there, because I think it's if it can be done in the short term, then it is definitely the right way to do it, because we spent a long time getting rid of Pivot Web, and bringing it back is not really desirable.
It was a fun adventure, but maybe would prefer not to repeat all of it.
Yeah, one other aspect of this is this, supposedly temporary workarounds or solutions. They tend to stick and become permanent. So if we can, not do it from the get-go, we should definitely not do it. Okay, I think one other aspect to mention here, and this is not in the pad, but there is because it's still work in progress, but we're also in parallel working on hashing out a unified set of metrics, Prometheus metrics. Right now is just between RBD and RBD mirror and CFFS mirror. There is a spreadsheet, but it hasn't been exported to the SPAN yet because it's only been, it hasn't been discussed yet and settled on. But we're working on making these metrics. Because both of these mirroring solutions are based on snapshots, and that makes it relatively easy to come up with a set of metrics that suits both RBD and CFFS, and that's what we're working on. The goal is to have something that would just again have a type label in the metric, but the metric name, the metric names would be the same, and so a consumer could look at these metrics, and whether it's a block volume or a file system volume, a consumer in the Kubernetes environment in particular would see the same set of metrics, or very similar set of metrics. I know we talked about, the long-term goal is also extending this to RGW, but I think that's probably harder because RGW's mirroring is more involved and could be is not strictly one way, and is also has more to it. Let's put it that way. But long term, the goal is also to incorporate RGW buckets, at least to some degree. And that's also why we want this library, the common piece that would be used by all the daemons, by all Ceph daemons, to expose a Prometheus endpoint. That's why we want that to be based on Boost Beast, so as to not introduce a separate web server into RGW.
Sounds great. Multi-site already does a little bit of perf counting and sends those through the manager. But if we do want to beef up how much we're sending, then we'll definitely have to switch to this strategy. Overall, sounds great to me.
It's the same for RBD. We currently send just a couple of counters, and the ask is to make this per volume or per image. So that's going to scale linearly with the number of images, and putting that load on the manager is just not something we want to do. Okay, it sounds like we have an action item. I think the most important one, because getting this common piece right is definitely a prerequisite for everything else. Is there anything else from anyone else?
Sounds like that's it for the Prometheus discussion. Any other topics folks wanted to bring up?
I guess I'll just ask one question. I'm just trying to understand better. So the high-level goal is to have a consistent system here, and that's connected to the types in Prometheus. So is that what the deal is, or I'm just trying to understand the consistency aspect?
The consistency aspect is really just between all the different mirroring solutions that we have today in Ceph. These are implemented, like there is one for RBD, one for CephFS, and one for RGW. They're all conceptually similar in that they provide a disaster recovery mechanism, and the high-level goal is to it's not so much down to the Prometheus's metric types, but deeper into like the individual metrics themselves, so that things like how far is your mirroring behind? So is it is it performing well enough, or is there a backlog of data? How many images or volumes are being mirrored? And then for each volume, what is the state? Again, is it up to date? Is it lagging behind, or is mirroring just stopped for some reason? These are the things that we want to expose in a unified way, so that to the end user, it does not matter whether it's a file system volume or a block volume. or in the future an RGW S3 bucket. We want obviously we wouldn't be able to hide all the distinctions there, especially when RGW comes into play. But the goal is to make that as unified as possible, so that the differences are sort of hidden, and the user gets a consistent view of how the Ceph cluster is doing with regards to disaster recovery, and basically with regards to mirroring to remote secondary Ceph cluster.
Yes, I don't want to open up a can of worms. It feels like that's a pretty opinionated statement. And it seems like it leads in the direction of asserting that that the replications are all semantically similar. If to the extent they actually are kind of similar, it makes great sense to try to have common idioms. So to that extent, I would agree with that, but I wouldn't want to state that the overriding goal is to hide the differences between different protocols that use Ceph and happen to be replicating, because we might want to vary the semantics even more than we already are, or we might discover that there already is enough variance that we care.
Yeah, I do.
To present unified front to the users. That's what I was wondering. So, but yeah, that makes sense to me. Thanks for explaining.
Yeah, Matt, and the goal is definitely not to preclude, I mean, it would be up to the individual daemon to, send whatever metrics it deems, necessary. Really, the short to medium term goal here is, because RBD and CephFS mirroring, at least to an extent that they are going to be used by Kubernetes, are both based on snapshots, and the mechanisms are really similar. You take a snapshot, and the deltas are then mirrored and applied. The realization is that these are sufficiently similar so that we could really present a unified set of metrics that would have exactly the same names and differ with just some labels, and it would still be obvious whether it's a block volume or file volume if you look at the labels, but the overall structure and I guess a way to interpret these metrics would be very, very similar. At least that's the goal.
Okay, thanks for the explanation.
Any more question on Matt's part?
I think that's it. Thanks a lot, everybody, for the great discussion. And we'll see you, everybody, month.